Good morning, everyone. It's been a long time since I have gone live on Facebook here. So, what we'll be looking at today is going to be atmospheric rivers and how they're affecting California. So, what's going on lately is that there have been a ton of floods for California. So, here's those actual precip totals. It was 240 inches. That is 20 feet of snow in Mammoth Mountain, where we see the pink here. So, it has just been a ton of moisture, and there's a good reason why. I've been tracking it all along, and believe it or not, it has to do with outer space. So, I shared a little bit the other day there. And of course, on my page, World of Weather on Facebook, Weather Woman, you can find a lot more information there. But what we're looking at today, and I'm welcoming you to all put any questions in the comments that you have, as a lot of what I'm going to share is not really out there yet. But I am a meteorologist with a degree. I have also earned my certificate for space weather forecasting. So I'm using this to kind of see some interesting things going on. Now, I've been using space weather to better forecast our weather here on Earth compared to the models for years. So what I'm seeing here is that there is a lot of moisture. Now green is where it's a lot of moisture. It's going to rain a lot there. If it's white, it's probably just clouds. If it's yellow, that's very dry air. So this is kind of high in the sky, near where the jets fly and where the tops of the thunderstorms will be. So these areas would be thunderstorms. What is going to happen here is some convergence. So we have this plume here heading toward the north. We have this batch of moisture that looks like it's atmospheric rivering again, as in sending out a lot of moisture because of how the air is squeezing together. It actually squeezes the air together and compresses it into that water molecule instead of being vapor, which is what we're seeing kind of in the blue area. You might see a clear sky there, but of course there is a gas that is just invisible in those areas where it's drier. So in that case, when these come crashing together, these two areas of moisture closer to the states, as this keeps traveling north and this keeps traveling and ends up digging down to the south, a secondary trough, what I call this is a trough going down, that will then affect the United States with this moisture back here and draw in some of this moisture here at the same time. So this is where I'm going to forecast that not just one more atmospheric river is heading to California, but probably two already, and it does have to do with moisture traveling across the equator. This is not common, but I'll show you another view of this now on windy.com. Excuse me. And then I'll dive into the space weather portion of this. So what I've been tracking now for the last, it's been about 6 to 8 weeks now, where I saw that moisture crossing the equator. As soon as I showed this, a friend of mine who has worked in the field of weather forecasting said to me, oh, this could be a signal of El Nino starting, which I had been forecasting for years. I forecast that based on the solar cycle data over here that I will show you in a moment. But this friend of mine says, oh, this is something that they used to use to analyze that, yes, it's happening. So what this means that I'll play the last 12 hours, give you a good idea of what's going on here, and scoot this over where the moisture is. Now, in this infrared satellite, this is from a satellite out in space looking down and analyzing temperatures. So if we're seeing some dark red spots, that's pretty cold. And usually that will indicate then that the cloud tops are very high. There's deep moist convection, so those clouds are overshooting into the troposphere where we see these really dark spots. Those will be the big thunderstorms. Now, with this going all the way across the equator is going to lie right around in here. We typically see thunderstorms right along the equator, called the ITCZ line, Intertropical Convergence Zone. So here is where normally we don't see this moisture leaving the equator and heading north. Now, I say we don't normally see that, but we do see it when we're changing our cycles from a La Nina, which is where this water over here, the top surface of the water, was cooler than average for a while, a few years. And that, by the way, is average, that it goes up and down. So, but the way that we call La Nina and El Nino is based on very small temperature variations. They will just change by 1 to 3, sometimes 5 degrees Celsius in this part of the world with the water. So if the South Pacific is below average with those few degrees cooler, then we typically get very dry patterns in the United States. We were just in a very massive drought here. But with the exchange, it was extra sunspots giving us extra heat and energy from solar storms that I do believe and will continue to research and help prove that this is a driving force in changing our weather patterns and switching to El Nino. So, again, this has been 3 to 5 years. I've been forecasting the climate 3 years with these tools and regular weather for 5 years more accurately. So, I have done this a while knowing that I don't see any flaws in this, and I've ran it by a lot of researchers now. So I'll continue to study this and write publications, but the gist of this is that the moisture, all in all, is traveling toward the west a little bit each day. I really gave a rough estimate, but I was saying about 200 miles a week. And then what we're seeing here in the last 12 hours, it's almost stagnant. We have, let's see, I'll wait for the end of the loop and I'll look at this westmost portion. It's not hardly changing at all. So in 12 hours, it went from about here to about here. So 24 hours, I feel pretty comfortable with that about 200 to 500 mile estimate of progression there every day. So very slowly, this has been traveling westward, and in this, we're starting to see now it's more dry, closer to Hawaii. So we have a batch of dry air here right now, but not in this area. So anytime that we have more of this moisture near the equator allowing to feed into the United States, there'll be more rain in the United States. And the further south it comes from, the more tropical that moisture is, like these over here, even stronger moisture plumes. If we get some of this moisture, it makes a huge difference in how much rain we get in the United States, because everything is based off temperature, density, and pressure when it comes to weather. These big differences, if we have this density, it's so much different here near the tropics compared to the dry air up north. So when those two features merge, like we're starting to see here, as some of this is feeding in from the south and from the north, when they come together, that's when we get even larger amounts of rainfall and the stronger winds. Everything wants to equalize in the atmosphere, just like most natural systems. So that's what things are working toward, an equilibrium. And in doing so, as this dry air and this moist air mixes together, it does so very rapidly to try to become the same. And when they're extra different, extra warm and very cold, and they come together, it's extra windy. So that's going to be affecting us with a pretty strong storm system next weekend, once again in the States after a little bit of a drying. There's this other next storm that's going to come through about Tuesday, Wednesday, Thursday, and that one will be also more rainy than what we just caught with the storm leaving the US, but not as rainy as the one to follow. Now, back to the solar cycle topic I was getting at. We have been tracking these things on the sun for quite a while. NASA continues to make some pretty nice videos on this. I would love to work with them someday and help create some. That made it a little bit too large, so here. I'll go back to this and just kind of give you an idea of what I mean about solar cycles. I'll leave this off, but what's happening is there's actual magnetic foot points on the sun. This is the sun's atmosphere we're looking at. And those loops, it'll have a south field on one side and a north field on the other. They're actual magnetic loops, and those are called foot points, where they touch down in through that sun's surface and atmosphere. Now, if it blasts stuff off like we just saw, we can get energy coming toward Earth if it's going in the right direction. Some of this stuff is going to change over time. We see sunspots go they can go pretty much gone when we have the south and north poles on each side. But every 10 to 15 years, they say 11 to 15, these fields change. So we're seeing these, what would happen with a north and a south pole on top, then all of a sudden when this is getting intertwined, what happens is there's actual north and south poles all over the sun. Now we see the reds and the blues kind of all over the place. And then it will be 11 to 15 years later after that, that once again we see the north pole on top of the sun and the south pole on the bottom. At those points, there's less solar storms. We see the downtrend there around 2010 when there weren't really any sunspots like these bright spots on the sun. That's what sends us the storms. And we get more of them when we're near those solar maximums. So we're about to approach another one around 2025 for this solar cycle 25 that we're in right now. It's looking like it's going to be a little weaker. That's what they were forecasting, and it actually hasn't been. I didn't really think it was going to be. I'd say a little weaker, but I do believe that that estimate they just had there is actually a little low. So nothing to worry about is what they're getting at now. These are trends that we've been dealing with for a long time. And since we've been doing that for over 200 years, we have these kinds of graphics from a couple of men. One Carrington, if you know about the Carrington event, he helped people understand what was going on there by literally just drawing what he saw. I did a microbiology experiment before we had cameras, and I was doing the same thing. It reminded me so much when I first saw this of how I was drawing the bacteria on the plates to correspond with what was happening in the experiment so I could log it. And so that's what he did for us. And in doing so, we've been able to get longer data sets. Look at this, back to 1700 with those same solar cycles. So what he was doing was counting how many sunspots are there. When that number started downtrending again, we were heading toward a solar minimum. And then we started seeing more of those sunspots. We head back up to a maximum where there's a lot of that solar energy coming our way. There's 4 main types of solar storms, and they do different things. That I can get into in a different video, but for the basis of this, we will know that these are not all the same. Kind of like our tornado years, we'll have some that are a little lower, some that are a little higher. And look at this though. Once again, it kind of seems like there's a general trend. And I have a friend who has 5,000 years worth of data that he uses, and I'm going to be learning more from him and sharing more on that. But what he uses is cosmic footprints and things like even where Jupiter is in relation to Earth and the Sun in order to say when we're going to have severe weather here in the United States 4 years from now. So these kinds of cycles are extremely powerful to use. And weather forecasting, I'm going to continue working with him to figure out exactly how we can better forecast them, because all in all, we've had fewer solar storms lately compared to what we can and what we know we probably will get again in the future. So this could be bad news with all of the extra satellites we have going up in the sky right now. We need to be extra prepared. So here we are progressing into solar cycle 25, relatively low compared to what we've experienced in the past. Now, there's a lot of talk that we're approaching a grand solar minimum. So funny story with climate change and people talking about global warming. It's not something I've ever been much of a fan of myself, and mostly because I talk to a lot of PhDs about the subject. So when I do speak with people who have meteorology PhDs, most of the time, they have said that there's no way we are more powerful than this. Yes, we know we can cause little changes in the climate. We can seed clouds. We can, maybe if we're putting a lot of roads down, we're going to make it hotter there. Where there's cities, we have what's called the urban heat island effect. Now we saw a big filament eruption here. So this is what I was hoping to see in this 304 angstroms here. This shows us a wavelength of the sun that lets us check out some of the darker filament eruptions. These are actually hotter in temperature, and this one would be coming right toward Earth, following magnetic field lines. So how I was talking about a few different types of these things, this in particular, a CME, I've noticed that it does increase our storm systems on Earth if they have a southward field. So those magnetic clouds that we just saw leave the sun actually increases our lightning if it is the electromagnetic energy. That one probably had both with it. How I can check that stuff I'll show you in just a moment. But what happens is typically we get a lot more lightning and storms with these. So I've noticed something that I want to go back and research then, is that these bomb cyclones, you may have heard that in the news lately. When our cyclones or our storm systems, the low pressure, drops more than 24 millibars in 24 hours or less, it's not always forecast by the model, and neither is that rapid intensification of hurricanes. I'm looking for lightning here, and I'm not seeing it because I wanted to show you. It just might not be loading, but I'm going to show you then how these couple of things go together on the Space Weather Prediction Center. It's here, SWPC is what we call it, swpc.noaa.gov. These are the people. I just met them all too, just about every single one of them. Is that Jenny? Yeah, so she just taught me She was my professor. I sat in this meeting with everybody virtually talking about space weather policy. So, if you want to learn anything, by the way, about what's going on with space weather, they've really been changing this website really nice to make it user friendly and help show people what this stuff means right there. So, it's clickable immediately. You can see, well, what are they talking about a radio blackout? What is a radiation storm? Yes, these things have biological effects, and we know that. So, how and to what degree? Well, it can make astronauts sick if they are going to be, let's say, changing a filter on a satellite and getting outside of a spacecraft in order to do that in the air. They're not going to want to go out if we're having an S5. So, that's why we started looking at this stuff. That's a radiation storm, a very high one, where they would probably be throwing up, and it could get worse than that. We have not fully tested, to my knowledge, what happens to a human being under those worst circumstances, but we know that radiation poisoning makes people sick and can cause cancer. So M-class flares, they have quite a bit of electromagnetic radiation with them. That's the stuff that increases our lightning, and you can catch that here on the GOES X-ray flux. Otherwise, what we're looking at in this one here is a very wonderful tool. It shows us not the sunlight. It's blocking that out right here in this blue zone. The actual sun takes up the space here inside the white circle. And what this shows us then is it eliminates that light really close to the sun so we can get a better view of what plasma is coming toward us. Now we saw that one discharge. These are a little bit on a different time code. So when we saw that filament eruption I just showed in 304 angstroms, like who knows what that is, the red sun. I've already closed it. Okay, never mind. When we saw that big chunk of plasma fall off the sun, that's where it was heading. It's this bright area here. Now you can think of the Earth as being where you are staring at the screen, and all these things kind of curve around when they follow the magnetic field lines. Because the sun is spinning around in this way, then the Parker spiral is created. There's a spiraling layer here of the magnetic field lines going this way. So when we have the storms eject here, it is actually what we call Earth connected. Those magnetic plasma bursts and clouds end up coming right toward Earth. And then if they have that southward field, which I'll show you down here, I've noticed and want to perform more studies on this idea, that it then increases our wind speeds, our cloud condensation nuclei, which means extra things are in the air. This is a southward field, BZ, when the red line is below the zero. And so that means that that magnetic cloud, a previous one that already came close to Earth from an eruption last week, that storm did affect us at Earth. It peeled back part of our auroral oval, part of our magnetic shield. What happens is we have a northward shield around the Earth, and if a south magnetic connection comes nearby, it will connect with that field, stop connecting, connect, so it goes back and forth here a lot, but on these periods, it's connected with that same magnetic shield around the Earth, and it peels it back in layers, affecting the poles faster. The North Pole and the South Pole will get these streams of energy quicker than the equator will. So with this being said, I have a very good feeling after years of observation that the studies I'm going to write will show that yes, these southward fields do affect our weather patterns. And if we can figure out the mathematics properly, I have a math degree, hooray, then we can go ahead and put these things into our computer forecast models to get better results than what we're seeing now. So this is incredible because, like I was saying, we have the historical data to back this stuff for a couple hundred years, going all the way back to here when we had our last grand solar minimum. There are 200-year cycles, and it does seem like perhaps things went a little higher. And then we had another chunk here where it was like the same as this period. Another chunk here, kind of the same, but a little bit stronger. And it looks like we're downtrending again into a period where there's less heat energy coming to Earth from the sun. So all in all, no, I don't think there's any global warming. And yes, I do think we're going to have a few more atmospheric rivers because of the solar cycle changes and what they have done to our ocean temperatures. It has been directly linked in some studies already that these solar storms and the El Nino and La Nina patterns connect, more could be written on that, more could be discovered. I plan on helping with that as well, but this here was proof enough to me. This big moisture plume last month was over here feeding in all of that moisture. And like I said earlier, typically these stay right on the equator and do not push moisture up into the northern hemisphere. But we are seeing this continue on for almost 2 months now, just drifted more further to the west. So pretty soon here, rather than California getting these atmospheric rivers, it could take a little bit of a turn in February and March, where we see then March becoming more of a super soaker for Thailand, March into April being India, as I've been tracking this plume. It does not seem like it's going anywhere, and it does appear to be getting more energy and more help to stay strong from these little bits of solar storms. So have a nice day, everybody. I hope you enjoyed that little overview of what's going on and my interpretations using my 15 years of school to help. So have a nice day. If you have any questions or any added input, please go ahead and share that with me in the comments below.